अजीज़ तलबा अस्सलाम वालेकुम। लेक्चर नंबर 8 लेकर डॉक्टर मोहम्मद तजम्मल चुगताई हाजिर हैं। आज के लेक्चर में हम कर्कॉफ्स करंट लॉ की मुख्तलिफ बिल्कुल आसान सी मिसालें देखेंगे। कर्कॉफ्स करंट लॉ की सादा सी मिसालों में हम सबसे पहले जस्ट इक्वेशंस को लिखने का हुनर सीखेंगे। उसके बाद हम कुछ कॉम्प्लिकेटेड सर्किट्स को लेकर उसमें मुख्तलिफ रजिस्टर्स के अक्रॉस या उनमें से करंट की वैल्यू या उनके अक्रॉस कुछ वोल्टेजेस की वैल्यूज़ को कैलकुलेट करना सीखेंगे। इस सिलसिले में सबसे पहले एक सादा सी मिसाल, लेकिन पिछले लेक्चर की निस्बत थोड़ी सी मुश्किल मिसाल जिसमें रेजिस्टिव कंपोनेंट्स को दिखाया गया है, लेते हैं और देखते हैं कि मुख्तलिफ नोड्स पर उसकी इक्वेशंस किस तरह लिखी जा सकती हैं। आइए स्लाइड पर देखिए। स्लाइड शोज a resistive network being supplied by a voltage source of voltage level V. Now, if we see it carefully, we can see that there are 4 total number of nodes. 3 of them, they have been marked as 1, 2 and 3, whereas the 4th node has been deliberately marked as ref or reference node. Now, this reference node will be considered as common to all the nodes. You can see that node 1, 2 and 3, they all are sharing this node. Therefore, the number of equations which we will need to write for this particular circuit will be 3. Let's try to write down the equation for node 1. Concentrating onto the node 1, we can see that current I1 is leaving the node. Therefore, we put a positive sign next to that. Also, we can see that current I2, which is leaving the node 1 through R2, therefore, we also put a positive sign next to I2. And finally, we can see that the current IS is approaching the node 1. Therefore, we put a negative sign next to that and we equate this expression to 0, and that is the equation for node 1. For node 2, at node 2 we can see that there are also 3 currents which are affecting the node 2. Current I2 is approaching the node 2. Current I3 is leaving the node 2 through resistance R3, and the current source having a value of 50 times I2 is showing that this current is also approaching the node 2. Now we try to write down the equation for node 2. Since I2 is approaching the node 2, therefore, we put a negative sign next to I2, that is minus I2. I3 is leaving the node 2, therefore, we put a positive sign next to that. And finally, 50 times I2 is also approaching the node 2, therefore, it will have a negative sign. And again, we equate all this expression to 0. Next, we move to the node 3. Once again, we can see that for node 3, current I1 is approaching the node 3 through resistance R1, and current I4 is leaving the node 3 through resistance R4. Also, the current source, which is having a value of 50 I2, is leaving the node 3. Therefore, our equation will be written as minus I1 plus 50 times I2 plus I4 equals 0. इस तरह से आपने देखा कि कैसे मुख्तलिफ नोड्स पर इक्वेशंस को लिखा जा सकता है। जब आप किताब में से कुछ प्रॉब्लम्स लेकर प्रैक्टिस कर रहे होंगे तो उसमें सबसे आसान तरीका ये होगा कि आप सबसे पहले मुख्तलिफ नोड्स को नंबर देकर मार्क कर लीजिए और उनमें से रेफरेंस नोड को भी आइडेंटिफाई कर लीजिए। इससे आपको निहायत आसानी होगी। उसके बाद जब आप इक्वेशन लिखने के लिए तैयार हो जाएं तो बगौर उसका जायजा लीजिए कि कौन कौन से करंट कौन कौन सी नोड को लीव या अप्रोच कर रहे हैं, और कोशिश क्या बल्कि करना ही पड़ेगा कि तमाम करंट्स को इक्वेशन में इंक्लूड करते जाएं। इसमें से कोई भी करंट को मिस आउट नहीं होना चाहिए, वरना आई एम अफ्रेड आपका जवाब गलत हो सकता है। इसके बाद हम थोड़ी सी मजीद पेचीदा मिसाल लेते हैं। इस मिसाल में भी हम इक्वेशंस को लिखना सीखेंगे कि किस तरह से मुख्तलिफ कंपोनेंट्स को कंसिडर करके नोड इक्वेशंस को लिखा जा सकता है। आइए स्लाइड पर देखते हैं। Slide shows quite a complicated circuit where the values of currents have been given in terms of milliampere quantities, and we want to find out the source current or the total current which is being supplied to the network, and that is dividing into the various branches of the resistive network. Therefore, we can say that for node A, 10 milliampere is entering the node. Node A में you can see that 10 milliampere value of the current is approaching the node A, and another value of 60 milliampere current is also approaching node A. Now, what is the value which is leaving the node A? That will be the total source current value IT. Now, if we want to write the equation for node A, we can write IT minus 60 milliamperes minus 10 milliamperes is equal to 0. Now you can see that we have taken the values positive which are leaving the node, and we have put the negative signs next to the values which are approaching the node A. Moving to node B. For node B, we can see that the 60 milliampere current is leaving the node B, whereas the current values of 40 milliampere and 20 milliampere are approaching the node B. Therefore, the equation for node B can be written as 60 milliamperes minus 40 milliamperes minus 20 milliamperes is equal to 0. And surprisingly, very interesting result, we can see that 0 is equal to 0. What does that mean? That means that no current is flowing through the node B. इसके बाद हम एक सादा सी सर्किट की एग्जांपल लेंगे जिसमें मुख्तलिफ वैल्यूज़ जो कि गिवन हैं उनके अलावा एक अननोन वैल्यू को भी दिखाया गया है ताकि आपकी प्रैक्टिस हो सके। आइए देखें कि तमाम वैल्यूज़ के जानने के बाद सिर्फ एक अननोन वैल्यूज़ के साथ किस तरह से इक्वेशन को लिखा जाएगा। The circuit shows a two-node network, so we will be bothered only for node A. Now, looking upon node A, we can see that 4 milliampere current is leaving the node A. Also, the current I is leaving the node A, whereas the 12 milliampere current is approaching the node. Therefore, we can write the equation using KCL or Kirchhoff's current law for node A minus 12 milliamperes plus 4 milliamperes plus I is equal to 0. अगली मिसाल में भी हम इक्वेशन के लिखने की प्रैक्टिस करेंगे, लेकिन इस मिसाल में दो अननोन क्वांटिटीज होंगी जबकि एक नोन क्वांटिटी को दिखाया गया है। आइए स्लाइड पर देखते हैं। दिस सर्किट शोज अ 3-node नेटवर्क। ऑफ कोर्स थर्ड वन is a reference node, so we ignore it, and we are left with only two nodes, that is node A and node B. The equation of current at node A and B by Kirchhoff's current law can be written as, for node A, I1 is approaching the node, whereas I2 and 3 milliampere currents are leaving the node A. Therefore, we can write the equation very easily as minus I1 plus I2 plus 3 milliampere is equal to 0. For node B, we can see from the circuit once again that the current I1 is leaving the node B. Also, the current value of 4 milliampere is leaving it, whereas the current value of 12 milliamperes is approaching the node B. Hence, we can write the node equation for node B very easily as minus 12 milliamps plus 4 milliamps plus I1 equals to 0. इससे अगली मिसाल में हम देखेंगे कि किस तरह से कुछ रिलेटिव या डिपेंडेंट सोर्सेज की वैल्यूज जो कि अननोन हों उनको कंसिडर करके इक्वेशन को किस तरह से लिखा जा सकता है। आइए एक ऐसा ही सर्किट स्लाइड पर देखते हैं। स्लाइड शोज देयर इज वन करंट which is marked as Ix and a current source which shows 10 times Ix current supplying to the network. Now, although we can see on the slide that there are 4 junctions, but still because on the top no component exists between the two dark pads, therefore they are considered as short circuits. Hence, we will consider it as a single node. Similarly, the second node is at the bottom, though there are two black pads which are shown, but still because they don't have any component in between them, therefore short circuit means direct relationship, therefore it will be considered as a single node. For the node A, we can see that the current Ix on the left hand side is leaving the node, whereas the dependent current source 10 times Ix is approaching the node. Further moving on to the right hand side, we can once again see that 44 milliampere independent current source is leaving the node A, and through the resistor a 12 milliampere value is approaching the node A. Therefore, the equation for node A will be minus 10 times Ix plus Ix plus 44 milliamperes minus 12 milliamperes equals 0. So if we see again that there are two currents which are leaving the node A, and the third one, which is 44 milliampere, that is approaching the node A. Therefore, the equation for this node can be written as Ix plus 10 Ix minus 44 milliamperes is equal to 0. अजीज तलबा, अभी हमने मुख्तलिफ सर्किट्स को लेकर उनके मुख्तलिफ नोड्स पर इक्वेशंस को लिखना सीखा। इसकी मज़ीद प्रैक्टिस के लिए आप बुक में से कोई भी सर्किट उठाकर और उसकी मुख्तलिफ नोड्स पर इक्वेशंस को लिखने की प्रैक्टिस कर सकते हैं। इससे अगली मिसाल में हम कुछ अननोन करंट्स को इक्वेशन के जरिए हल करके कैलकुलेट करने की कोशिश करेंगे। आइए स्लाइड पर देखते हैं। We want to calculate the values of I1 and I2. Now, looking upon the circuit, the standard practice will be that first of all, we identify the nodes. So, we mark two nodes as A and B on the top, whereas right at the extreme bottom of the circuit, there exists another node and we consider it as a reference node. Now, we consider the top A and B nodes one by one and try to write their equations. For node A, I1 is approaching the node A, so we write minus I1. 8 milliampere is leaving the node A, so we write plus 8 milliamperes. Also, 4 milliampere is leaving the node A, and we equate this equal to 0. Rearranging this equation, we can easily calculate the value of I1, as this is the only variable which is unknown to us. Therefore, I1 is equal to 12 milliamperes. Now, in order to calculate I2, we again have to see carefully what are the currents which are leaving and what are the currents which are approaching the node B. नोड टू नोड मूव होते हुए जब आप इक्वेशन लिखने की कोशिश कर रहे हों, तो किसी भी नोड पर पहुंचकर आपको निहायत मुहतात अंदाजे से ये देखना होता है कि कौन कौन सी करंट वैल्यूज नोड को अप्रोच कर रही हैं और कौन कौन सी करंट वैल्यूज उसको लीव कर रही हैं, ताकि इक्वेशन लिखते वक्त आप उनको प्रॉपर साइंस असाइन कर सकें। नोड बी के लिए आइए इक्वेशन देखते हैं। फॉर नोड बी, 8 milliampere is approaching the node B. Therefore, we write minus 8 milliamperes. We also observe that 2 milliamperes is leaving the node B, therefore plus 2 milliamperes. And also I2 is leaving the node B, therefore we again write plus I2 and equate it to 0. Therefore, we end up with I2 is equal to 6 milliamperes. अजीज तलबा, इससे अगली मिसाल में हम देखेंगे कि अगर किसी सर्किट में करंट और वोल्टेज सोर्स टुगेदर दिए हुए हों तो उसमें इक्वेशन को किस तरह से लिखा जाएगा। नेवरदलेस अगली आने वाली मिसाल में हमें रेजिस्टेंसेस की वैल्यूज नहीं बताई गई हैं, लिहाजा लामुहल्ला तौर पर हमें इन सोर्सेस को इग्नोर करना पड़ेगा, जबकि हर नोड पर कुछ ना कुछ करंट वैल्यू बता दी गई है, इसलिए हमें इन सोर्सेस की जरूरत नहीं रहती। आइए स्लाइड पर देखते हैं। We want to calculate the values of I1, I2 and I3. Now, looking on to the circuit, we can see that there are 4 nodes into this circuit, A, B and C, whereas the 4th node has been taken as a reference node. Now, to start with, let's start from the node A. I1 and I2 are approaching the node A, whereas 8 milliampere value at the top of the circuit is leaving the node A. Therefore, the equation will be minus I1 minus I2 plus 8 milliamperes equals 0. Rearranging it, we can write as minus I1 minus I2 is equal to minus 8 milliamperes. Therefore, we end up as I1 plus I2 is equal to 8 milliamperes. For node B, we can again visualize that the current I2 and I3 both are leaving the node, and the current source 4 milliampere is also leaving the node B. Therefore, we can write the equation as I2 plus I3 plus 4 milliampere is equal to 0. Rearranging it, we can write the equation in terms of I2 and I3 as I2 plus I3 is equal to minus 4 milliamperes. For node C, we can see that I3 is approaching the node C. 2 milliampere is leaving the node C. Are these the two currents which are affecting the node C? No. We also must include the value 8 milliamperes right onto the left hand side on the top of the circuit. That is also approaching the node C. Therefore, 3 currents are affecting the node C. The equation for node C will be minus I3 plus 2 milliamperes minus 8 milliamperes equals 0. Rearranging this equation, we can write I3 is equal to minus 6 milliamperes. अजीज तलबा, अब तक हमने इस मिसाल में मुख्तलिफ इक्वेशंस लिखी जिनमें मल्टीपल वेरिएबल्स का इस्तेमाल हुआ है, यानी कि कुछ इक्वेशंस में एक से ज़्यादा वेरिएबल्स आ गए हैं, लिहाजा एक एक वेरिएबल को कैलकुलेट करना पड़ेगा। आखिरी नोड सी में हमने I3 की वैल्यू को कैलकुलेट कर लिया है। अब इस वैल्यू को लेकर पिछली इक्वेशंस जो हमने डिराइव की हैं उनमें पुटअप करेंगे और इस तरह से हम ईच एंड एवरी करंट वैल्यूज को कैलकुलेट कर पाएंगे। आइए देखते हैं किस तरह। पुटिंग द वैल्यू ऑफ I3 इन इक्वेशन ऑफ नोड B, we can write as I2 minus 6 milliampere equals minus 4 milliampere. Therefore, I2 is equal to 2 milliamperes. Now, we will put up the value of I2 into the equation for node A. Therefore, we can write minus I1 minus 2 milliampere is equal to minus 8 milliamperes. Therefore, I1 is equal to 6 milliamperes. अजीज तलबा, इससे अगली मिसाल में हम थोड़ा सा पेचीदा सर्किट लेकर उसमें मुख्तलिफ नोड्स के ऊपर इक्वेशंस को लिखना सीखेंगे। आइए स्लाइड पर देखते हैं। The slide shows quite a complicated circuit. In this circuit, the use of voltage source and current source both have been made. Some of the current values, they are known, whereas some of the current values are unknown to us. Now we will do the practice how to write the node equations for various nodes. Standard practice, we will identify the nodes first. So you can see at the top, we have marked the node as node A. Then coming down from A, the node has been marked as C. On the left hand side, the node has been marked as B, and on the right hand side, the node has been marked as D. Whereas the extreme bottom node is left open because it is considered as a reference node. Now we will try to write the node equation for each of the node one by one. For node A, minus 5 milliamperes because it is approaching the node A, plus 8 milliamperes because it is leaving the node A, plus 4 milliamperes because it is leaving the node A as well. You can see extreme right top corner of the circuit, which is having an independent current source of 4 milliampere value. So it is also regarded as the current leaving the node A. Therefore, we equate this expression to 0. For node B, we can also inspect that I1 and 5 milliampere current values both are leaving the node B, whereas current value I2 is approaching the node B. So that we can write the equation as I1 minus I2 plus 5 milliampere equals 0. Now for node C, we can see that there are 4 currents which are affecting the node C. I1 is approaching the node C, therefore we write minus I1. 2 milliampere is also approaching the node C, therefore minus 2 milliamperes. 3 milliamperes is leaving the node C, therefore we write plus 3 milliamperes. And once again 8 milliampere is approaching the node C, therefore minus 8 milliampere equals 0. For node D, we can see that 2 currents, 3 milliampere and 4 milliamperes, they are approaching the node D, whereas another unknown quantity of current, I3, is leaving the node D. Therefore, we can write the equation as minus 4 milliamperes because this is approaching to node D from independent current source, minus 3 milliamperes. This current is also approaching the node D, plus I3 equals 0. I3 we have kept it as a positive quantity because it is leaving the node D. Dear students, अभी तक हमने मुख्तलिफ नोड्स की इक्वेशंस को लिखना सीखा. अगली मिसाल में हम देखेंगे कि मुख्तलिफ नोड्स पर किस तरह से वोल्टेज वैल्यूज को कैलकुलेट किया जा सकता है. अगली मिसाल में हमें रेजिस्टर्स की वैल्यूज भी दी गई हैं. उसके अलावा कुछ करंट वैल्यूज को भी दिया गया होगा, जबकि हमने मुख्तलिफ नोड्स के ऊपर वोल्टेज ड्रॉप्स की वैल्यू को निकालना होगा. इस सिलसिले में अब तक जिस तरह से हम मुख्तलिफ नोड्स को ए, बी, सी, डी वगैरह से नॉमिनेट करते आए हैं, जब हमें वोल्टेज कैलकुलेट करना होगी तो हम इन नोड्स को V1, V2, V3 की सूरत में नॉमिनेशंस दे देंगे ताकि हमें मुख्तलिफ इक्वेशंस लिखने में आसानी रहे. आइए स्लाइड पर एक ऐसी ही मिसाल देखते हैं. स्लाइड शोज क्वाइट अ सिंपल सर्किट which is comprising 3 nodes. The one reference node is at the bottom and that is shown with the ground. In this example, we have been shown with a single current source which is having a value of 6 milliamperes. The rest of the currents which you can see flowing in terms of arrows, they have been drawn later on. Now, for the sake of simplicity, we have drawn these arrows in a way that all of these currents are assumed that they are leaving the respective nodes. You may be surprised how we can do that. If you remember, in the earlier lectures, we have already mentioned that it does not matter which direction you assume for the current to flow. It will only make the difference of a negative sign, which can be corrected any time. Therefore, in this example, we have considered that all the currents apart from the given current are leaving the respective nodes. Let's see now how to deal with such an example. We have identified the 2 nodes by giving them the names V1 and V2. We have node 1 and 2, whereas the third node is shown as a reference point, and this is the general practice to show graphically in the form of a ground connection as well for the reference node. Now, because we want to calculate the voltages at the node number 1 and 2, therefore, we designate the voltages at these nodes as V1 and V2 so that we will have a convenience while writing the equations. Now, at node 1, V1 divided by 12K plus V1 minus V2 divided by 10K is equal to 6 milliamperes. From this equation, you don't need to get confused. अगर ओम्स लॉ को देखें तो ये असल में हमने करंट्स को ही लिखा है. सिर्फ ओम्स लॉ को अप्लाई करके करंट को वोल्टेज और रेजिस्टेंस की फॉर्म में लिख दिया गया है, क्योंकि यही वैल्यूज हमें अवेलेबल हैं. आइए इस इक्वेशन की फर्दर प्रोसेसिंग देखते हैं. बाय रीअरेंजिंग द इक्वेशन वी कैन गेट 5v1 plus 6V1 minus 6V2 is equal to 60K into 6 milliamperes. Now, kilo and milli will cancel each other onto the right hand side of the equation. Therefore, by simplifying the equation, we can write 11V1 minus 6V2 is equal to 360. At node 2, we can write V2 divided by 3K plus V2 divided by 6K plus V2 minus V1 divided by 10K equals 0. Rearranging it, we can write 10V2 plus 5V2 plus 3V2 minus 3V1 equals 0. This will give us 18V2 minus 3V1 is equal to 0. Now, we try to equate the two equations for the node 1 and node 2. Therefore, putting them together, we can end up as 30V1 equals 1080. That will give us V1 is equal to 36 volts. That will mean that at the node 1, the voltage with respect to the reference node will be measured as 36 volts. Now, in order to calculate V2, we put up the value of V1 into the respective equation. To write down 18V2 minus 3V1 is equal to 0, or 6V2 minus V1 equals 0, or 6V2 minus 36 equals 0. Therefore, V2 is equal to 6 volts. Now, the current I naught also needs to be calculated. Therefore, I naught is equal to V2 divided by 6K. That will give us 6 by 6K is equal to 1 milliampere. Dear students, आज हमने कुछ सिंपल और कॉम्प्लिकेटेड सर्किट्स को लेकर उनकी नोड इक्वेशंस को लिखना सीखा। मज़ीद हमने सीखा कि जब कुछ वैल्यूज़ अननोन हों तो KCL को अप्लाई करते हुए उनको किस तरह से कैलकुलेट किया जा सकता है। अगले लेक्चर में हम KCL की ही मज़ीद पेचीदा मिसालों को कंसिडर करेंगे। लेक्चर 9 तक के लिए इजाज़त दीजिए। खुदा हाफिज़। अजीज़ तलबा, अस्सलाम वालेकुम। लेक्चर नंबर 9 लेकर डॉक्टर मोहम्मद तजम्मल चुगताई हाजिर है। पिछले लेक्चर में हमने कर्कॉफ्स करंट लॉ से मुतल्लिक मुख्तलिफ छोटे छोटे सर्किट्स का इक्वेशन लिखना सीखा था। आज के लेक्चर में हम थोड़े से पेचीदा सर्किट्स लेकर उनमें मुख्तलिफ नोड्स पे वोल्टेज डिफरेंस या फिर उसकी मुख्तलिफ ब्रांचेज में से करंट के फ्लो को कैलकुलेट करेंगे। इस सिलसिले में कुछ एग्जाम्पल्स आपके लिए सेट की गई हैं। आइए स्लाइड पर देखते हैं। शोन एग्जाम्पल is comprising two current sources. First of all, we will look for the number of nodes carefully which are possible for this circuit. So we can see clearly that there are 3 nodes. Now, as our practice, we can take one node as a reference node. Therefore, we are left with 2 nodes. Now our task is to calculate the voltage at these 2 nodes. First of all, we start by designating 2 numbers to these 2 nodes, node number 1 and node number 2. Now, because we want to calculate the voltage difference at these 2 nodes, therefore, for our convenience, we give those voltages the names as V1 and V2 as it is shown in this slide. Now, first of all, we consider node 1. Applying